The concept of functions involves three things: two sets, let's see for example this and this, and a rule of assignments. So a rule that assigns to each element of A an element of B. For example, it could be this one. So we have assigned to each element of A an element of B. This first set is called the domain of a function, and the second set, the set that have the element that have been assigned to the first set, is called the codomain. The element that is assigned to the element of A is called the image of that element. For example, in this case, we say that the image of 1 is 2, that the image of 2 is 4. And to symbolize that the function assigns number 2 to this number 1, we write f of 1 equal 2. And we understand that the image of number 1 under the function f is equal to. Or we can say that the image of 2 is 4. So we can type f of 2 equal 4. And we read it in this way, f of 2. And the image of 3 is 6, so we can type f of 3 equals 6. And the image of 4 under this function f is 8. This notation is useful because we can actually define the rule using this way. In this example, we notice that for each number of the first set, we have assigned 2 times the element. For example, for number 1 is 2 times 1. For number 2 is 4. For number 3 is 2 times 3. So, and for number 4 is 2 times 4. So actually, in this case, we can say that the image under the function f of any element is 2 times the elements. And this is the way that we use to define a function, to define the rule. We read it f of x, but we need to understand that this means the image of the element x under the function f. So for example, if you have g of x equal x plus 5, that means that for each element in the domain, we are going to assign under the function g an element that is the same element plus 5. So for example, if 1 is an element of the domain, then the image of 1 will be 1 plus 5. The image of 0 will be 0 plus 5. The image of 3 will be 3 plus 5. And we notice here that whatever real number can be an element of the domain. We say that the natural domain of this function is the set of all real numbers. So I know that the function involves 3 things: 2 sets and a rule of assignments, but in some occasions, especially in applications, we don't express what will be the domain, what will be the codomain. We are going to be using as the domain the set of all possible real numbers to which you can assign something with the rule. In other cases, like this, f of x equal x squared minus 1 over x minus 1, we are saying that the image of x under the function f is achieved raising x, the number, to the power 2, subtracting 1, and then at the denominator typing the same number minus 1. So the image of 2, for example, will be 2 squared minus 1 over 2 minus 1. But here we notice that number 1 cannot be part of the domain, because if we try to find the image of number 1, at the denominator we're going to see that it will be 1 minus 1, and it will be a 0 at the denominator, so this will be an indetermination. So 1 cannot be part of the domain. We can say that the natural domain of a rule like this is all the real number except number 1. So number 1 cannot be part of the domains. So we notice that in this case, 1 cannot be an element in the domain of this function f. And we also notice that 1 will be the only element that is not possible to be part of the domain. We say that the natural domain of this function is the set of the real numbers except 1. Or we say the set of real number minus number 1. So in the case of the function gx equal x plus 5, if we want to find the image of 2, so the image of 2, the function says that the image of any element is the same element plus 5. So the image of 2 will be 2 plus 5. and this will be 7. So it means that the function g assigns the number 7 to this number 2. Or for example, if we want to find the image of -1, the image of -1 will be then -1 plus 5. So just make a substitution wherever you see the x, you substitute by the number to get the image. So here I see the x, so it will be -1 plus 5, and -1 plus 5 is 4. Or if I want to know the image of 0, then I substitute the value of x by 0, will be g of 0 equals 0 plus 5. So g of 0 will be 5. And if we are speaking about functions like this g, when the domain and codomains are subset of the real numbers, there is another concept, the concept of limit of a function, that is related to a function of real numbers. The next table will show the image of elements taking values closer and closer to 1. So we're going to see what happens if x takes values closer and closer to 1. And we are going to see this in the table. So we have the table. Here I'm going to type the value of x, and here will be the image of x under the function y. What happens, for example, if the value of x is 0? So closer to 1, so what I need to do is just substitute x by 0. So it will be 0 plus 5 equal 5. This is making here. So it will be equal 5. What happens, for example, if the value is 0.9? So now the value of x is closer to 1. So if this is 0.9, then the value of g of 0.9 will be 0.9 plus 5. And this will be 5.9. So it will be 5.9, the image of 0.9. If I go closer to number 1, let's say 0.99. So if I substitute here, 0.99 plus 5 will be 5.99. And we notice that the closer we go to number 1, the image of the element gets closer to number 6. So if we get even closer, 0.9999, the image of 0.999, it's easy to see that it's 5.9999. And we notice that the closer we get to number 1 for the value of x, the closer we get to number 6 for the image of the x. We say that the limit of gx as x approaches to 1 is number 6. But we are approaching to 1 taking values lower than 1. These values 0, 0.9, 0.99, 0.999 are lower than 1. So actually what we are going to say is that the limit of gx as x approaches to 1 from the left is number 6. And we write it in this way. The limit of gx as x approaches to 1 from the left, so taking values lower than 1, and we are going to type this minus here as a power of 1. It means approaching from the left. So we say that the limit of gx as x approaches to 1 from the left is 6. But what happens if x approaches to 1 from the right? So it means taking values greater than 1. For example, number 2. So if I take number 2, the values, so making a substitution here will be 2 plus 5, it will be equal 7. So the image of 2, we know that it's 7. So the gx takes the value of 7 when x takes the value 2. But what happened closer to number 1, for example, 1.1. So if this is 1.1, so it will be the value of g will be 1.1 plus 5. It will be 6.1, the value of g. So now, again, we are getting closer to number 6 when we are approaching to 1. But let's see what happens if we are even closer to 1. Let's see 1.01. And if we have 1.01, it will be 1.01 plus 5. This will be 6.01. So this will be 6.01, closer to 6. So again, when we are getting closer to number 1, from the right now, the value of the function, the value of the image of x is getting closer to number 6. So we say then that the limit of gx as x approaches to 1 from the right is also 6. And we're going to type this way. And we're going to speak this way. we say that the limit of gx as x approaches to 1 from the right is 6. If the limit from the left and the limit from the right, when x approaches to 1, if these two limits are the same, we are going to write then that the limit of the function as x approaches to 1, and I'm not going to say left or right, it will be equal 6. So this is actually the meaning of the limit. So it means that when x takes value closer to 1, the function takes value closer to 6. It doesn't matter if they are closer from the left or closer from the right. This is the concept of limit. Another example could be the other function, limit of x squared minus 1 over x minus 1. And let's see again what happens if x takes value closer to 1. Because I noticed that I cannot make a substitution of x equal 1. But the value of x could be whatever other. What happens if the value of x is closer to 1? Here we notice that if we make the substitution x equal 1, will be 1 plus 5 equals 6. So just making a substitution, I will notice what will be the limit of the function as x approaches to 1. But what happens in this case when 1 is a value that is not part of the domain of the function? So let's see what happens. Let's make another table for this, and the value of x, the value of fx, and let's see what happens if, for example, x equals 0. So there is a value closer to 1, but it's lower than 1. And I notice that if x is 0, then I make a substitution here, 0. This will be 0, so actually will be minus 1 over minus 1. So that will be 1. What happens if x is not 0, but x equals 0.9? The only that I need to do is substitute the value of x by 0.9. 0.9, 0.9 here. So it will be 0.9 squared. This is 0.81 minus 1. And this will be 0.9 minus 1. What we have is negative 0.19 divided by negative 0.1. Use a calculator and just make a substitution. So you will notice that it will be equal 1.9. If I substitute by 0.99, make a substitution here, please use your calculator, 0.99 squared, and here 0.99. You will notice that the value is 1.99. Or what happens if you substitute 0.999? Then you will notice that the value of the function will be 1.999. So we observe that if the value of x approaches to 1, taking values lower than 1, then the value of the function approaches to 2. So it means the limit as x approaches to 1 of fx equal 2. So let's see what happens if x approaches to 1, but now taking values greater than 1. So what happens if x approaches to 1 from the right? So if x equals, for example, 2, then we substitute x by 2. Here will be 2 to the power 2, that will be 4. 4 minus 1, so there will be 3 at the top. So and here at the bottom will be 2 minus 1, so it will be 1 here. So it will be 3 over 1, so it will be 3. So the value of f of x is 3 when x is 2. But let's see what happens if x approaches to 1. Let's see, for example, if x takes the value 1.1. So it's greater than 1, but closer to 1 now. And make a substitution here, 1.1 squared, this is 1.21. And here will be 1.1. So make the substitution and you will notice that the value will be 2.1. So let's see what happens if we approaches even closer to 1. So there will be 1.01, for example. Make a substitution here and you will notice that the value will even closer to 2. It will be 2.01. And if we approaches even more, 1.001, the value of f of x will be 2.001. And again, we notice if x approaches to 1 from the right, the value of x approaches to 2. We can say then that x approaches to 1 from the left or from the right, then the values of fx approaches to 2. The limit of fx as x approaches to 1 from the left is equal to the limit of fx as x approaches to 1 from the right, and will be in both cases equal to. So we say the limit of fx as x approaches to 1 equal to, because these two limits from the left or from the right are the same. But we notice that in the first case, this limit can be obtained just substituting x by 1 in the definition formula of g. So we put here 1, so we will have 1 plus 5. This 1 plus 5 will be equal 6. So the limit as x approaches to 1 of gx equal 1 plus 5 equals 6. Sometimes we can make a substitution and we can find the limit. This is a case. And there will be other cases where that substitution is impossible. So let's make a substitution. The limit of gx when x approaches to 1 will be just substituting x by 1. So it will be the limit of x plus 5 when x approaches to 1. And this is just 1 plus 5 equals 6. We just make the substitution. We can say it's g of 1. So the image of 1 is actually the limit when x approaches to 1. However, there are other cases, as in the second case, when making a substitution is not enough. So it's impossible to make a substitution for it in this case. If making the substitution we obtain a 0 at the denominator, so this division cannot be made. There is something more here. There is some kind of indetermination here. If you substitute x by 1, here will be 1 squared minus 1 equals 0. And here at the bottom it will be 1 minus 1, 0. This indetermination is of the form 0 over 0. If that is the case, we can modify this algebraically in such a way that we can find factors in one or in both of numerator and denominators. So for example, here we notice that the numerator is an expression that can be factored. So if that is the case, if the indetermination is 0 over 0, one way to get the limit without making this type of substitution is just factoring, or find a way to get an equivalent expression in which appears factors at the numerator, at the denominator, or in both. To compute the limit of x approaches to 1 of x squared minus 1 over x minus 1. So this is f of x. And we notice that here we can factor. This is actually the difference of squares. So this is equivalent to the root of the first minus the root of the second multiplied by the root of the first plus the root of the second. So we can say that this limit will be equal to the limit of x minus 1 multiplied by x plus 1 over x minus 1. And now we notice that this minus 1 can cancel. So we eliminate these two, and then actually this will be the same of the limit when x approaches to 1 of x plus 1. So this function x squared minus 1 over x minus 1 is equal to this function if x is different than 1. So if x is different than 1, because they are taking values closest to 1 but without 1, so it means for all these values they can be cancelled. And then because the limit of x plus 1, now this is a function when I can make a substitution without any problem. So we notice that this is 1, making a substitution will be 1 plus 1 equal 2.